Hello everyone. This video let's learn set and subset. Some basic terminology. A is a set of students registered for this class. This is a word description. We use a sentence to describe a set. B is a set of 1, 2, 3, 4, 5. So we list all of the elements of B. 1, 2, 3, 4, 5. In the braces, we have a lot of elements, all of the elements of set B. We call this method raster method. And number C. C is equals 2, 4, 6, 8. This is also a raster method. List all of the elements in the braces of C. Let's see, D. D is equals all of the x such that x is a counting number less than 6. We call this one set builder notation. I don't have to list all of the elements of the D, but we will show the condition of the variable x. And then you will know what is the D, the set D. How to read this? We say all of the x. And this bar, we call the such that. And then you read the descriptions or the conditions. X is a counting number less than 6. If I convert this one to the raster method, or we say list all of the elements of D in the braces, what should I do? D is also equal to, so let's read the description. X is a counting number less than 6. What is a counting number? 1, 2, 3, 4, 5, 6. So starting from 1, yes, 1 is a counting number less than 6. 2, 3, 4, 5. And I cannot list 6 because I'm looking for the element which is less than 6. Totally, we have 5 elements in this set D. Okay, let's see. E is also a set builder notation. E is equal to all of the x such that x is an even counting number less than 10. If I want to convert it to the raster method, so we will list the E. Okay, x x is an even counting number less than 8. Even counting number, they are 2, 4, 6, 8, 10, etc. So we're starting from 2, first even number, second even number, 4, and 6, 8. So can I list 10? Is an even number less than 10. I cannot list 10. 10 is equal to 10. All right, we list all of the elements of E. Next one, let's convert the raster method to the set builder notation. F is, the elements are 1, 2, 3, 4, 5, 6. They are counting numbers until 19. So into the set builder notation, I'm going to list F is equal to all of the x such that x is the element of F. X is an counting number. Less than 20. You can also say is less than or equal to 19. Is not an. Okay. Let's see next part. There is a special set with no element. So the previous examples, like these, we have some elements in the braces. And here we have some elements. Even the word description, we still have elements in the set. But now there is no element in the set. So in your braces, you see nothing inside. We have the notation, this notation or this notation. Second, so we call them empty set, or this notation we call the phi. That means empty set. Sometimes the empty set is a disguise. Okay, what's the meaning of disguise? So let's read the set builder notation. A is a set for all of the x such that x is greater than 5 and less than 2. Okay, let's find some element satisfy this condition. Is greater than 5 and less than 2. If I have a number line, this is 2, this is 5. The element is greater than 5. For example, 6, 7, 8, 9, 10. But at the same time, it needs to be less than 2. It must be 1, 0, -1, etc. So there is no such number satisfy the first condition on the right and at the same time on the left of this number line. So there is no such element. So A is empty set. So A is phi. Okay, set membership. So this symbol we called is a member of or element of. Second notation means is not a member of or element of. Okay, for example, let's see this. 3 is 3 element of the set 3, 5, 7. Okay, in the set 3, 5, 7, we see there is an element 3. So 3 is an element of the set 3, 5, 7. I'm going to use the notation is an element of or a member of. So 6 is 6 an element of 3, 5, 7. In the set on the right, we have 3 elements, 3, 5, and 7. There is no 6. That means I need to say is not an element of the set 3, 5, 7. Let's see next one. 15 blank a set. So in this set, they are all counting numbers less than 21. The counting numbers are from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to 20. And the inside of the set, one element is 15. Even we have 3 dots here. That means the number between 3 and 20. So 15 is an element of the set. Even I didn't show it didn't write the 15, but you must know 15 is inside of the set. Okay, let's see next one. 3, and the set on the right is for all of the x such that x is a counting number with x is greater than 4. X is greater than or equal to 4 or less than or equal to 9. That means all of the element of x is 4, 5, 6, 7, 8, 9. At least the set builder notation in the raster method. So these are all of the elements. And 3 is not an element of the set. So I'm going to say is not an element. Let's see. 8 is an element of 5. So I know that this notation means inside of my braces, there's nothing inside. Nothing. That means 8 is not an element or is not a member of 5. All right, let's see next part. Here. There is a special abbreviation for counting number or natural number. We will say n. but for some textbook, we will use cursive N, for example. So we are using cursive N, something like this. I'm not good at drawing the cursive N. So N represent counting numbers, starting from 1, we have 2, etc. Okay, let's see, cardinal number and cardinality. The cardinal number or cardinality of the set A is number of elements in the set A. So for example, if I have a set A is equals 1, 2, 3, let's count how many elements inside of this set. 1, 2, 3. So the cardinal number or cardinality of A is 3 because totally we have 3 elements. We say N of A equals 3 because totally we have 3 elements. Okay. Determine the following cardinality numbers. Notation of cardinality, we say N of A. So N of the set 2, 4, 6, 8. How many elements inside of the set? We have 4 elements. We say cardinality is 4. And next one. So N of the set for all of the X such that X is a member of N. N is counting numbers. So the condition is X is greater than or equal to 4, less than or equal to 12. Okay, let's use raster notation to describe the set. So the counting number starting from 4, 5, 7, oh, sorry, I forgot the 6. Where's my 6? 6, 7, 8, 9, 10, 11, 12, that's all. Okay, how many elements here? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So cardinality is 9. Okay, how about next one? If we use the same method, we can list all of the elements in the set. So N of X is a natural number and the condition is here we need to have parentheses. So don't forget you have a parentheses here, parentheses. Okay, so let's list all of the numbers. The condition is X is less than 4, less than or equal to 4. If I have a number line, here is 4. And greater than 7. The number is smaller than 4. They are 3, 2, 1, 0, negative 1. And at the same time, it needs to satisfy this number is greater than 7. I don't have any number satisfied both condition. That means the set is an empty set. There is no element, no such number in the set. So no number cardinality is 0. All right, let's see. What is the cardinal numbers of the set? 2, 2, 4, 6, 8. In the set notation, we don't do the duplication or repeat any numbers. If we have 2 elements, they are the same. We can ignore one. So we can just ignore it. We don't repeat inside of the set notation. All right. So this one means we have totally 4 elements. 2, 4, 6, 8. We have 4 elements. So cardinality is 4. Okay, let's see. Equivalent set. Equivalent set. Set are equivalent if they have the same cardinality. Number of elements. Determine if the following pair of the set are equivalent sets. So first one, how many elements inside of the set? 5 elements. So N of, let's say, the set is A. N of A equals 5. How about, let's say this is B. How about the B? N of B. We have A, B, C, D, E. We have 5 elements. That means set A and B, they are equivalent. How about the second one? So for all the x such that x is a natural number with x is greater than 3, greater than or equal to 3, less than or equal to 8. Let's use a raster notation to write the set. So this means x is starting from 3, 4, 5, 6, 7, 8. And how many elements do we have? We have 1, 2, 3, 4, 5, 6. We have 6 elements. Another set we have 1, 2, 3, 4, 5, 5 elements. So the cardinality are not the same. We say it is not equivalent. Let's see next one. For all of the x is an element of natural number with x is less than or equal to 2 and x is greater than or equal to 11. Let's draw a number line. We're having the x is less than or equal to 2 and greater than or equal to 11. I don't have a number that is less than 2 at the same time is greater than or equal to 11. So the first one is an empty set, nothing inside of the braces. We can also say it's a phi. Cardinality n of an empty set is 0. And the right hand side is phi. Phi, the cardinality is 0, 2. So they are equivalent. They don't have any element inside of the set. So they are equivalent. Next one, in the set we have 1, 2, 3, 4. And on the right, we are having 1, 2, 3, 4. This is equivalent because they all have the same cardinality 4. So they are equivalent. They are exactly the same. We also say they are equal. And we say they are equivalent because of the cardinality are the same. All right, let's see. Equality of the set. Sets are equal if they have the same elements. For example, the previous one, they have the same element. So we say this is equal. They are equal. And we use this notation to describe, to say they are equal. Let's see if two sets, they are equal. On the right, we have 1, 2, 3, 4, 5. On the left, we have A, B, C, D, E. They don't have the same elements, even they have same cardinality. So they are not equal. Next one, for all of the x, such that x is a natural number or x is an element of natural number with x is greater than or equal to 3, less than or equal to 8. If I have a number line, this is 3, this is 8. And x is between 3 and 8 and including 3 and 8 because of the equal sign. So in the raster notation, list all of the elements. They are 3, 4, 5, 6, 7, 8. And on our right, we have 3, 4, 5, 7, 8. So they are exactly the same elements. So we say they are equal. And next one. So let's see the description of the natural number x. X is less than or equal to 2, greater than or equal to 11. So this number is less than or equal to 2 is here. And at the same time, it needs to satisfy is greater than or equal to 11. So I don't have any number that both is here at the same time is on the right hand side. So this is an empty set. On the left is an empty set. The right one is also empty set. Yes, they are equal. And the last one, we have 1, 2, 3, 4, 5, 6, 7, 8. And on the right, we have 1, 2, 3, etc. until 8. So what's the meaning of here? That means the natural number or counting number between 3 and 8. So 1, 2, 3, 4, 5, 6, 7, 8. All right. Yes, obviously, right and left set, they are exactly the same. So we say they are equal. Let me ask you a tricky question. If I have a set 1, 2, 3, and I have another set 2, 1, 1, 3. Are these two sets equal? Some of you say, no, they are not equal because we have 3 elements in the first set, 4 elements in the second set. But you see, we have a repeated ones. That means I can ignore 1. That means I can just ignore 1. Just keep 1, 1. And some of you say 1, 2, 3. Another side is 2, 1, 3. They are not equal. But in the set notation, the order doesn't matter. You can rearrange 3 of them. You don't have to keep the order 1, 2, 3 or 3, 1, 3, 2, 1. So these two, they are equal. Because they have exactly the same 3 elements. All right, let's see subset. A set A is a subset of B. If each element of A is also an element of B. All right. So A and B, they are all set. And if A is a subset of set B, if each element of A is also in B, so notation is A is a subset of B. Think of B as a menu and a subset A as an order from the menu. Okay, fill in the blanks with the either is a subset or is not a subset. Okay, the first set is 3, 7. The second set is 3, 5, 7. I see element in the first set has 3, has 7. There also appears in the second set. That means yes, the first set is a subset of second set. All right. How about the second example? Second example, the 2 elements in the set, they are 3 and 6. Let's see if we have 3 and 6 on the right hand side. We have 3, we don't have 6. That means the set is not a subset of the second set. Next one, 4, 5, 6, and they eliminate, or they just use the dots to represent the number between 6 and 13. And on our right, we are having the counting number starting from 1 to 20. So do you think the right-hand side, the set on the right, is a subset of the left-hand side is a subset of right-hand side? Yes. If I expand the right and the left, you will see these numbers or this element, it is inside of the set on the right. They are the elements on the right. So I'm going to say it's a subset. Next one, 1, 2, 3, 4, 5, the set is a subset of 5 or not? It is not. Because in the empty set, there's no element, there's nothing inside, or we shouldn't say anything. We just say empty set, nothing inside. This element is not an element of the subset of the set phi, empty set. Okay, let's see. Phi is an element of ABC, set ABC. Yes or no? Think about it. I'm going to say yes. Okay, let's memorize that. The empty set phi is the subset of every set. So on your notebook, on your note, let's write down. The empty set is a subset of every set. Let's memorize that. Okay, next set, 1, 2, 3, is a subset of 1, 2, 3. Yes, it is, because the element on the left, they are also the element on the right. How about phi? Phi and phi, they are all empty set. So phi is a subset of empty set phi. Okay, let's see proper set. A set A is a proper subset of set B if each element of A is also an element of B. It's very similar like the subset. But A is not equal to B. Okay, B has more options has more elements. So A cannot equal to B. The notation is A is a proper subset of B. Fill in the blanks with either a proper subset or is not a proper subset. Okay, so 3 and 7. So 3 and 7, they are all inside of the set 3, 5, 7. Yes, and also the first set and second set, they are not equal. They are not the same. I'm going to put proper subset notation. All right, how about the second one? I think it reads messy. How about the second one? 3, 5, 7. So 3, 5, 7, all of them, they are inside of the right-hand side set. But A and B cannot be equal. So the first set is not a proper subset of the second set. They cannot be equal. Okay, 4, 5, 6, 7, until 13. And on the right is 1, 2, 3, then etc. 20. So these elements is right inside of the right-hand set. So all of the elements is in second set. So is a proper subset, and also they are not equal. Okay, next one, 1, 2, 3, 4, 5, 6, 7. Do you think the left-hand side is a proper subset of the left-hand side? I don't think so. Why? Because they are exactly the same. So if I expand this one, I'm going to have 1, 2, 3, 4, 5, 6, 7 is exactly on the same set on the right, on the left. So I'm going to say it's not a proper subset. How about the phi? Phi is an element of all of the set. So phi is a proper subset of the set ABC. And also the phi is not equal to ABC. And the last one is a tricky one. How do you think? Is a proper subset or not? Is not, because they are equal. If they are the same, I cannot say the phi is a proper subset of phi. They cannot be the same, be equal. Okay, let's see. How many subset of the proper subset does a set have? First, let's see, starting from phi. If I have a set phi, what is the cardinality of phi? How many elements in this empty set? Nothing. No element. So cardinality is 0. And the subset of A, subset of empty set is empty set, is phi. How about the proper subset? The proper subset cannot be equal to phi. That means none. Number of subset. So subset, we have only one element in the subset. The subset number is 1 because phi is the only subset. And how about number of proper subset? Is none, so it is 0. So messy. How about next one? If I have the set A only have one element here. So cardinality is 1 element. Subset of A is phi. Phi is a subset of all of the set. And how about another subset? It is A. Proper subset is phi because I cannot choose A. Set A is equal to the set A. So I cannot choose the equal one. And number of subset, we have 2 elements here. So we have 1, 2. So the number of subset is 2. Number of proper subset is 1, is the phi only. Okay, how about A and B? The set has 2 elements, A and B. Cardinality is 2. And what is the subset of A? So subset of A definition means all of the element in the this subset is inside of the site A. And we say always phi. And A and B, they are all in the set A, B. Also itself, A, B. So we have 4 elements. And how about the proper subset? I cannot choose A and B because they are equal. So we have 3 elements here. Okay, number of subset, we have 4. Number of proper subset, we have 3. Okay, how about next one? We have 3 elements, A, B, C. So cardinality is 2. And we list all of the subset. So subset, they are empty set. A, B, C. And A, B, A, C, B, C, A, B, C. And for the proper subset, I cannot say A, B, C. We can only choose the other sets. So number of subset, we can count how many do we have. So we have 1, 2, 3, 4, 5, 6, 7, 8. Let's put 8. And number of proper subset is 1 set less than the subset A of A. So we're having 7. So for example, we have a set has a lot of elements. How to find the number of subset? We are having a formula. It is 2 to the nth power. The n means how many elements inside of the set, or the cardinality. If the set has n element, then 2 to the nth power minus 1 is a proper subset, because we need to eliminate the ABC, the equal one. All right. How many subset are there of the set A, B, C, D, E? So how many elements do we have? We have 5 elements in the set. So we're having 2 to the 5th. So totally the subset is 32. How many proper subset are there of the set A, B, C, D, E? That is 2 to the 5th. And then minus 1, which is the set A, B, C, D, E. All right, this is 31. Next example, a pizza can be ordered with some none or all of the following toppings. So we have pepperoni, sausage, mushroom, onion, peppers, black olives, green olives, hamburgers. There is no my daughter's favorite cheese. So we have 1, 2, 3, 4, 5, 6, 7, 8. So 8 kind, but there are no cheese. How many different pizza are possible? What is asking for? It's asking for the subset. So the subset is 2 to the 8th. So 2 to the 8th is 2, 5, 6. So we, if we want to order some, none, or all of the following toppings, we're having 256 way to choose or possibilities. In this example, what would correspond to the empty set? Empty set, that means, what is that? Is 5 or nothing in the set. If, let me see. We have pepperoni, sausage, and then we have hamburger, a lot of toppings. But the only one we don't have is cheese pizza. So the cheese pizza. So the cheese pizza is not inside. Is not an element of the set. So I'm going to say correspond to the empty set, the cheese pizza. All right.